Hello, this class is for class 8th and the topic we will cover today is factorization, and there will be multiple classes or multiple sessions. So this is for part 1. So let's start. So when someone says about factorization, what does mean a factor? Factor basically when you work on any factorization or expression of a factor or uh, factor between two expressions, basically we are looking for common. Okay, so common, it can be a small and or it can be multiple of that common itself. For example, if I talk about common between 6 and 8, so what's common? Common is 2. You can divide 6 by 2 3 times, and you can divide 8 by 2 4 times. Or if I say about common between 6 and 12, again one of the common will be 2. Okay, you can both divide by 2. But if I ask about uh, greatest common factor about 6 and 12, that will be 6. You can't find a number bigger than 6 and which is common between these two numbers. Okay, but this is all on the numbers or digits. How about expressions? So let's talk about expressions as well. I will clean this one. So let's talk about the expression. So let's say the first expression is 2x and the second expression is 12x square. So what's the factor or common? So, or I would say what's the greatest common factor or highest common factor? So since these two expressions both has constant and the variable, basically 2 is constant, x is variable, and 12 is constant, and x square is a variable. So we will calculate greatest common factor, or in normal language or most of the time we say simply says common. So what's common between 2 and 12? It's 2, right? And when we talk about what's common between x and x square, it's x. So basically common between 2x and 12x square is 2x. I can divide 2x by 2x and 12x square by 2x as well. This will go one time, and x, it's 6, basically 6x, this part. So the common between 2x and 12x square is 6x. Let's take another example and see if we can find another. So let's talk about, this time we will play with the three expressions. So first one is 7x, second one is 21x square, and the third expression is 14x y square. So if question is what's the common or greatest common factor or highest common factor for all these three expressions, the very first thing is we need to identify what's common for the constant part. So 7, 21 and 14. Okay, what's the highest? Means anything which you can't find a bigger number with which you can divide all these three numbers. So it's simple, answer is 7. Now comes to the variable part. So x square, and here your expression is not just x, it's xy square. So what's the something which you can divide? X square, x and y square. So since y is only with one expression, so y cannot be. The very first thing is x is available in all three expressions, x square and xy square. However, x square is only available in this second one, so which cannot be a common. So the answer here is x. So the common between 7x, 21x square and 14xy square is 7x. Basically you can divide all these three expressions with the 7x. So if I divide 7x by 7x, that is 1. I can divide 21x square by 7x, that is 3x. And I can divide 14x y square with 7x, that will become 2y square, right? Yeah. So let's try with another expression and let's learn about it. Let's take another example of 42x square yz, and second expression is 63x cube y square z cube. So these are the two expressions we have. Okay, so as usual, what we did in the previous questions, first figure out the common between the constant. Okay, so 42 and 63, this time number is a bit bigger. Okay, so what we will do, we will break it. Okay, so what will be the, once you break 42 and 63, so 42, how you can break? Normally 42 you can come up with like 7 multiplied by 6, you can't break 7 further, but 6 you can break, so 6 you can make it 6, 2 multiplied by 3. In the same fashion, if you go for 63, this is 7 multiplied by 9, right? Again you can't break 7, but you can break 3. So what will be the common between 43 and 63? 7 and 3. So 42 and 63, your HCF highest common factor will be 21. So now the second part, which is expressions. So what expressions we have? We have x square yz. Okay, yz, this is not square, this is yz. And second expression we have x cube y square z cube. So the very first part is what you, this is can be solved by just by looking. You don't even have to, you know, write as well. So here you can see x, y, z, all three are available in all both the expressions. Now we will go. The very first thing is x, y, z or x, y, z. All three are there. Okay, but there are powers in these two expressions. So in the very first expression there is yz only 1. However, in the second expression it's y square and z cube. So highest what will be the common, and the highest it's only power 1. So yz will be always yz. It won't be y square or z square or y cube or z cube. Now let's come to the x. Here it's x square and here is it's x cube. So x square is common. So here common will be x square. So if someone talks about the common between 42 x square yz and 63 x cube y cube and z cube, so for the constant we got 21, and for the expression or variable part we got x square yz. So this will be the HCF for this expression, these two expressions. Okay, let's take another example. So till now we were taking one or two or maybe three. Let's try with the more than three expressions. So the very first expression, 9x squared. Oops. Second expression is 9x squared. Second expression is 15x squared y cube. Third expression is 6x y square, and fourth, let's say it's 21x square y power 5. Okay, so we have 1, 2, 3 and 4 expressions, right? So just like in the previous questions, what we have done, we have two parts, constant and the variable. So let's first figure out the constant part. 9, 15, 6 and 21, right? This is not 27, this is 21. Now let's break it. 9 can be 3 cross 3, 15 can be 3 cross 5, 6 can be 2 cross 3, and this can be 7 cross 3. Now let's see what's the common. In all three expressions, the constant part common is HCF is 3. Now comes to the variable part. In the first one it's x square, second one x square y cube, third xy square, and the fourth x square y power 5, right? So from the first expression there is no y, so it cannot be common, it can be only x, right? Now the question is what's power. So in the first expression we have square 2, second expression again 2, third expression 1, and fourth expression x square. Because even though first, second and fourth has x square, but the third one has only x, single x, only power 1. So hence the HCF will be x. So constant will be 3 and variable will be 3x. So if we talk about the common or HCF of all those four expressions, my answer will be 3x. Okay, yeah, let's take a couple of more. So till now we have taken 3, 4 or 5 expressions, constant and variables. Now let's take an example where we have different sign as well. So let's say the first my expression is for a square b cube, second expression minus 21 a cube b, and the third expression is 18, sorry, third expression is 18 a power 4 and b cube. Okay, so that's the expression. So let's try the expression. The first expression is for a square b cube, second 20 minus 21 a cube b, and the third one is minus 18 a power 4 and b cube. Okay, so let's see what we can do here. Okay, so let's just think about three expressions, and as similar to the previous questions, we have constant and the variables. So very first part is let's find out the common between the constant. So 4 minus 21 and minus 18. So let's break this one. It's 2 cross 2. This is minus 7 cross 3, and this is minus 6 cross 3, or instead of 6 you can say 2 cross 3 cross 3, right? Let me write it properly. So this is 3, this is 3. So what's the common? Tell me. So here if you see that we have in this expression this 4 minus 20 and 18. So do you find it here there is no 3, here is no 2 or 7, and here is 2 and 3. So there is nothing common, right? So we haven't found anything common between constant, so there won't be any HCF doesn't HCF won't have any constant part. Now let's figure out or work on the variable part. So all three has a, so that's for sure as part of the HCF, and all three has b as well. Now the query is, or the question is, what should be the power of a and b? So let's see in the its first expression x square, a square, a cube, and a power 4. So what's the lowest one? A square. Right, now let's see about the b. Second one is cube. First expression is b cube. Second expression is only b, and third expression is b cube. So the smallest one is b. So if I talk about a common RHA for these three expressions, this will be a square b, and since there is no constant here, okay, but let's change the constant here. So instead of 21, if I say 12, so now this will be minus 12, right? So what can be minus expression of minus 2? This will be 2 by 2 multiplied by 3. Now let's see what will be the common. So 2 all has, so there will be 1 2, but there is no double 2 or like 4, and there were no 3. So the HCF or the common between 4, minus 12 and minus 18 is 2. Okay, and even this will be basically plus 2, not minus 2, because only these two has minus sign, okay, but not the first one, so hence it is plus 2. But what if this is minus 4, right? So here it will come as a minus sign. Now it's 2 again, but with the minus sign. So HCF for these three expressions will be minus 2a square b. Okay, let's take few more examples and learn more complex expressions. Now let's say the expression is 2x cubed y square minus 10x square y cube, and the third expression is 14xy. Okay, same. Very first part is find constant common between constants. So 2 minus 10 and 14. What's common? 2, because there is nothing less than 2, right? 1, of course, 1 will be always common, but it's not the highest, so we don't count that one. Okay, now x y expression between x and y. So all three expressions has x, and all three expression has y2. So what I will do, I will write x and y, but I don't know what will be the power of whether x square or x cube or y cube, right? So let's see. In the first expression it's 3, second expression it's square, and in the third expression it's just 1 power. So what we will do, we will go with only 1 power, so there won't be an x square or x cube. Now let's go for the y. This is y square, this is y cube, and in third expression it is just y, so we can't go with any power as well. So the answer for this is 2xy. Okay, now let's try for a few more, and let's say 14x cube y power 5 minus 10x power 5 y cube, and the third expression 12x square y square. Similar fashion, in the similar method जैसा पहले किया है, पहले में 14 minus 10 and 12 common. Let's break it. 14 2 multiplied by 7, 10 minus sign with 2 multiplied by 5, 12, 2 multiplied by 2 multiplied by 3. So what will be common? 2. Nothing else, neither 7 nor 5 or not 3, it's not available, and only one expression has minus sign, so it's just 2 as a constant. Now x and y, all three has x y both, so I will simply write x and y. Now see what's the power, maximum power. So here it's 3, here it's 5, here it's x square, so the lowest one is x square. Now let's see y, 5, 3 and a square, so we'll go with the square. So the answer for this is 2x square y square. Okay, so now let's increase the complexity and see if you can do this one. Now, so far what we have tried to calculate, we have tried to calculate the common factor or greatest common factor. Now, question is how it's related with the factorization. So let's see, we have expression or uh, say we have three variables, and let's see, first try with the highest common factor, and then we will go with the expression. Okay, sorry. First expression is 5 a raised to the power 4. Second expression is 10 a cube, and the third expression is minus 15 a square. So what will be common? Let's see. So the very first constant part will be 5 as a common, right? Now see what can be the next. A in all three, so I will write a, but what will be the power in the first 4? Cube and square, so I will go with a square, and only 15 has a minus sign, so it's not common, so I will go highest common factor will be 5a square. Now let's utilize in the factor. Say my expression is 5a raised to power 4 plus 10 a cube minus 15 a square. Basically all three variables for which we were calculating or finding the common or highest common factor, I put that into expression. So 5 a raised to the power 4 plus 10 a cube minus 15 a square. Okay, now let's see. So we know the common was 5a square. So what the same expression I can write as 5a square, bracket starts. Now if we I take 5a square common from 5a raised to the power 4, what I will leave with a square. Okay, now let's go with the second part. Here is plus sign, so I will go with the plus sign. Now 10a cube. Okay, if I take 5, so we will uh, calculate it individually, constant part and the variable part. So if I take 5 out of 10, I will leave with 2. When we see common, basically we are dividing. Okay, so 10 divided by 5, it's 2, and then comes the variable part. Here it's a cube, here it's a square. So what I will have to, if you divide a cube by a square, you will have a. Now again go through the third expression. It will be, since this is minus, I will write minus. Now if you take 5 common from 15, it will be 3. And if you take a square common from the square, you won't have anything, or basically 1, so we won't write that. So factorization of this expression is 5a square in within brackets a square plus 2a minus 3. Okay, so that's how common factor is being used for factorization. Let's go with another example of factorization. Say my expression is 3x minus 9. I want to factor it. Okay, let's make a better x. Okay, my expression is 3x minus y. So I will use the common. What will be the common? Only here constant, so it cannot be variable, so only constant for 3 and 9. It will be just, sorry, it will just 3, and then bracket. Within bracket, if you take 3 out of 3x, it will be just x minus sign as it is out of 9. If you take 3 common, you will have a 3 remaining. So the factorization of 3x minus y will be 3 within brackets x minus 3. Or basically if you multiply it, you will get the same 3x minus 9. This will multiply and then this will multiply. Okay, so this is 3x minus 9. This is the same expression. Okay, now let's try a little bit complex one. So if I have expression, say 2xyz plus 3x square y plus 4y square. Let's see if we can do that. Let's pause video for a 30 seconds and try to figure out if we can do that. Okay. So here what's constant? 2, 3 and 4. Do you think there is anything common between these three constants? Nothing. So there is no constant part. Now let's see in the variable part. First one is x, y, z. Second is x square y. Third one is 4yz. Okay, this is z. Okay, so in the third expression there is no x. In the middle expression there is no z, right? So it cannot be x or z cannot be part of common. So let's try with the, do you see y in all three? Yes, we see y in all three, and there was no constant. So we will start with y. If later stage, if we find anything more, we will add that as well as a common. But for now, we just identified y. Then my bracket will start. Then if you 2xy, if you take y common, when I say y common, I am dividing it, right? So I will have 2xz plus 3x square, 3x square y, it will cancel out. There is no z, plus 4. I am taking y, there is no x, only z, right? So that's the fact. And let's see, do you have anything again common between these three expressions? 2, 3, 4. Of course, there is no constant common expression which can be taken common or highest common factor, and then you see the variable part xz, x square and z, right? So there is no common when it comes to variable as well. Okay, so this will be my final answer for as a factor for this expression. Okay, now let's try one more, and say my expression is 5x minus 15x square. So what we did earlier, same. See the common between constant part. Constant is 5. My bracket start. Then x minus x square. Okay. Now x square, x and x square, you have a common x. So you could have taken x at the initial, or you can take it later as well. I'm just trying to explain you step by step. Okay. 5, if you x and x, if you take another x common, so this will be 1 minus x, right? Or just like in the previous, what you have done, my expression was 5x, sorry, my expression is 5x minus 15x square. What I will do, common is 5 from constant part, and if I go by the variable part, x and x square, x is common in the same line, so this will be minus 3. Okay, I missed this one here. So when you took common from 15, here it will be 3x, right? So I missed that. 5 multiplied by 3, that's 15. So 1 and if you take x common from x square, this will be x. So the factorization of 5x minus 15x square is 5x within brackets 1 minus 3x. Okay, now what I will do, I will take even more complex expression. Let's try that one. Let's go with the expression something like 2x cube y square minus 4x square y cube minus 8x y power 4. Okay, so let's see the constant part. 2, 4, 8. What will be the common? 2 will be the common, right? Now let's see the variable part. X cube, x square, x, third expression. Of course I can take x as a common. Now let's see, do we have common in the y? Okay, so first y square, y cube, y power 4. So y square, y cube, y power 4, what will be the common? Y square will be the common. So took y square, bracket start. Now let's see from the first expression the remaining. So 2 already we have taken common. Out of cube we have took x, and out of y square we took y square. So only part remaining is x square, because here it was 3 power cube, right? And then second expression minus sign will come as it is. If you take 4, 2 common from 4, you will have 2, and then x square, you took 1x here, so you will have 1 remaining x, and then now you take common y square from y cube, you will have 1y as well. Now the third question minus as it is. Okay, we are not changing anything. And then if you take 2 common from it, we will have 4. Okay, then x has only 1 power. We already took x as 1 power, so there won't be any x remaining for within the bracket. Now for the y, here y has power 4, and here we have y square, so the remaining part will be y square. Okay, and after taking a common or putting in brackets, we will just take another look if we have found anything more common. So x square, 2xy, 4y, there is no constant to common, or even when you go for the variable, there is nothing common in the variable. In this one there is no y, in this one there is no x, so we can't take anything common. So this will be my answer. Okay, let's try one more expression. Now let's take another example. 6xa plus 7ya. You might be surprised why I have used a and x and y and a. Normally we use a, b, c, or x, y, z. Okay, but just stay with me. Okay, I will explain. So this is my expression. So it's a simple expression. There is, if I want to factorize it, there is nothing common for the constant. However, for the variable part, we have a common. So I will take a common, and within brackets I will have 6x plus 7y. Okay, now similar to this one, if I have say expression something like 6x and within brackets 2x minus y plus 7y, and in the bracket 2x minus y. Do you see any similarity between these two expressions? Okay, it's same. Only thing is this is a and this is a. This 2x minus, write it properly, this 2x minus y expression, okay, I have replaced with the a, so this left hand expression will become, or if I put value a as 2x minus y, my right hand expression, right? So now what we did common, we took common a. Same here, a is nothing but my expression 2x minus y whole, and then within bracket you will have 6x plus 7y. This is nothing but a. Okay, so what we have done so far, instead of looking at individual a, b, c, or x, now we are going with the entire expression as a common or highest common factor for the factorization. Okay, and let's see another one. Let's say I have expression of 9a within bracket. Let me write it properly and close. 9a within bracket 6a minus 5b. Second expression, second part of the expression, minus 12a square within bracket 6a minus 5b. Okay, just like the last example, what we have common, we have this expression as common. Okay, but at the same time we have to check what's from remaining expression, do we have anything common. So from 9 and 12, what can we take common? We can take common 3, right? What common we can take? We can take common as 3. So we will take 3, and then what about the expressions? This part is already common, 6a minus 5b, but along with that other part we have a as well. So 3 from 9 and 12, then a from a and a square, and then the expression 6a minus 5, 6a minus 5b. Then I will start another bracket. What's remaining from the first part? What was the first part? This part. So 3a 6a minus 5, the only part remaining is 3. Then minus sign as usual, this one, and then from 12a square, so the constant part will be 4, and out of a square we took a common, so this will be a, and 6a minus 5b we took entire expression common, so nothing else. So the factorization of this entire expression will be 3a within bracket 6a minus 5b, and in the second bracket it will be 3 minus 4a. Okay, let's explain one more thing. So now let's see if you have example expression, say 5x minus 2y square plus 3x minus 2y. Pause and try if you can achieve the factorization for this entire expression. Okay. Okay, so let's try this one. Is there anything common in the constant part? Here in the first part it's 5, second 3. There is nothing common, so we can't do anything. But now the variable part, if I consider this as a, right, so I can write this as a 5a square plus 3a. Okay, now do you see anything common? Yes, it's easily visible. A you can take common. So what will I have here? 5a plus 3. Now just simply replace the a, x minus 2y. So x minus 2y within bracket 5, a is x minus 2y, but within bracket, so one more bracket, x minus 2y plus 3. If you want, you can simplify this expression. So this will be x minus 2y, 5x minus 10y plus 3. Okay, yeah. Okay, let me give you one more. So let's say you have this expression 2x minus 3, or okay, let me give another expression, not that one. Okay, before that let me give you a formula for factorization. A square minus b square. Okay, this formula is a minus b and second bracket a plus b. Okay, this is a very common formula and it will be used at multiple places. A square minus b square is equal to a minus b into a plus b. Okay, if you want you can expand this and you can see, multiply this a with these two expressions, so this will be a square minus a b, and then you multiply this b with remaining expression. So because b has a plus sign, so I will put plus, and then this will become ab, and plus minus is minus, then b square. These two things cancels out, so a square minus b square. Okay, so this is the formula that we have proved here as well. A square minus b square is equal to a minus b into a plus b. Trust me, this formula will be used a lot for in the factorization. Okay, and you need to learn to identify this formula as well. Let me give an example. For example, you have formula called 49 minus x square. This is the expression. Okay, so do you see here how you can apply this formula? A square minus b square. So 49 is nothing but whole square of 7, and then x square. Now can you see, if you can apply this formula, this will become 7 minus x, another bracket 7 plus x. Using this formula is common, b square is equal to a minus b and a plus b. Okay. Okay, so let's try one more expressions. Okay, now what I will do, I will increase the complexity of the expressions. So let's say you have p square q minus p r square minus pq plus r square. You have to factorize this one. Okay, so earlier till now what we are doing, we will have 2 or 3 expressions, okay, or part of the expressions, and each part will have something common. Okay, but if you see here, we have 4 parts and nothing is common across all 4. Okay, so what we will do here, we will try to break into 2 parts. Let's see if we can get a common from 2 parts, and there's something similar, we can make an expression of the remaining. Okay, so let's see with the first part. Okay, so pq and pr, do you see anything common? We see p common, right? What will be here? Pq minus r square, then pq plus r square. I have done nothing, I just put the expression as it is. If you see here, you have something similar, this expression. Okay, the only difference is with the sign. So what I will do, I will do first expression, I will keep as it is, pq minus r square. Now if we write to minus as a sign common, okay, what will be expression? This one, this will be q minus r square. Okay, now this entire expression is common, right? So I will take that entire expression as common, pq minus r square. If you take count from the first part, what will have? P, right, minus, there is nothing here remaining, so it will go as a 1. So the expression or the factorization of this expression is this, pq minus r square, another bracket p minus 1. So basically common may or may not be available very uh, visibly in the first time. Okay, you have to you have to take common from the expressions and see if you can find a pattern there. Something similar, let's try 1 plus xy plus x plus x square y. Do you see any common between these expression? 4 parts, 1 xy x and x square plus y. Okay, do you see anything common? I don't. So what we will do, we will try with the whatever we can take common from the existing expressions. So let's say, if you see here, if I arrange this 1 plus x plus xy plus x square y, in this expression x and y is common, right? So I will take that plus xy, then this will be only 1 plus, from here it will be x. So do you see here, 1 plus x and 1 plus x, this is common as an expression. So I will take 1 plus x entire, so 1 plus x, this entire x, first left part is 1 plus x, so what will I have in the bracket? 1 plus, from here if I take 1 plus common, I will have remaining 1y. So x factorization of this expression is 1 plus x, another bracket 1 plus xy. Now let's say another expression. We have xa square plus xb square minus ya square minus yb square. Okay, that arrow. So now let's take common. So the first two parts, can you see? I can take x as a common, so I will have xa square plus b square. Now from the second part I can take y, but I can take minus y as a common, because if I take minus y, bracket within that, it will be everything in plus. So what I will do, I will take minus y, within bracket I will have a square plus b square. Now I can take entire expression as a common, a square plus b square, another bracket x minus y. Okay, now if I make little bit changes into this expression. Okay, so let's say the second expression is xa square minus xb square. Okay, x square minus xb square plus ya square minus, sorry, yb square. Okay, let's see, here x common, here y common, so I will take x here, a square minus b square plus, here y common, I will take y, a square minus b square. Now a square minus b square is common in both, so I will take that as a common, then x plus y. You remember earlier I told you formula for a square minus b square. So now in this case I have to apply, so it will be a minus b, a plus b, and then this x plus y. Okay, so you have to keep factoring or keep taking expressions common wherever till there is nothing common to take. Okay.